Hello class, welcome once again to our session. Today we are going to continue our discussions on solvable groups of trigonometric integrals, group number 2. And group number 2, integrals of this form. Okay, so we have in this form where m and n or where m and or n are positive integers. Last time we had discussed case 1, okay, and then I'll give you one example, and then we solve example for case 2. So today we're going to discuss case 3, and I'll give you another example for this case. So for case 3, where m is even and the integrand is tangent only. Okay, so you just use the identity tangent squared u equal to secant squared u minus 1. Okay, for example, if you're given this, so how will we solve this one? So using case 3, so if you look at the given, our m is even, okay, then there's only tangent here, so tangent only. So we have to make use of this identity class, trigonometric identities. Okay, so I will show you the solution for this problem. So our given is the integral of so you cannot be seen. So the integral of tangent to the fourth x dx. So this is case 3. So in case 3, so for case 3, m is even and only tangent. So the integrand is tangent only. Okay, so if this is the case, then we have to use the identity. Okay, use the identity tangent u equal to secant squared u minus 1. Okay, so what we're going to do now is to break this integrand into two parts so that we can produce tangent, tangent squared. So we can rewrite this as so this is equal to the integral of, we can rewrite this as tangent squared x multiplied by tangent squared x dx. Okay, then after that, use this identity. So we can rewrite this integrand in terms of secant squared. Secant squared x minus 1. Okay, so they're just the same, so you can copy. Secant squared x minus 1. And then everything is multiplied by dx. So you can multiply this first term to first term, then so you just distribute the integral sign later and also the dx. So integral of secant squared times secant squared, so that is secant to the fourth x. Okay, so we put this inside the parenthesis, then we have to multiply the first term and the second term, so that would be minus, because this is minus, this is plus, so this is minus secant squared x. Then next we have to multiply the first term, sorry, the second term and the first term, this one. So this is minus, then this is positive, so this would be minus secant squared x. Okay, and then we have this one, second term and the second term, so minus times minus, so that is plus, so negative 1 times negative 1, so that is positive 1, and multiplied by dx. Okay, or we can rewrite this as integral of, so secant to the fourth x, then we have here, we can combine these terms, so they're just the same. So combining them, this is minus twice secant squared x, then plus 1 times dx. Okay, then if you look at the first term, so that falls to case. So what case is that? When there's secant only. So if you are going to examine case 2, in case 2, when n is even. Okay, so if you can still remember for case 2. So the rule here is, the scenario here is that when m is even, okay, what is m? Sorry, n. When n is even and greater than 2, right? So what is n? N is the exponent of secant. Okay, that is the exponent of secant. Even and greater than 2. So the rule here is factor out secant squared u du and replace the remaining secant by tangent. And then use this identity, secant squared u equal to tangent squared u plus 1. So we have to apply this case for our first term here. Okay, so the first term here, we have to apply case 2, rule in case 2. Okay, so in case 2, we have to factor out secant squared u du. So in other words, you have to factor this or express this into two factors, break this into two factors. So this can be written as integral of secant squared x times secant squared x, then minus 2 secant squared x plus 1 dx. Alright? Then after that, change. So we can now we can change this. Okay, so we can change this in terms of tangent using this identity. So equal to the integral of, change this in terms of we apply here case 2 as well. Okay, so in case 2, as shown a while ago, so for case 2, m is even and greater than 2, so we have to factor out. So we have to factor out secant squared u du. Okay, factor out secant u du. And then after that we have to change secant squared u. So we have to change this to tangent squared u plus 1. Okay, so applying this case 2 for the first term, that's why we break the first term here, secant to the fourth x, into secant squared x times secant squared x. Okay, so rewriting this, express this in terms of tangent, so this can be written as tangent squared x plus 1. Okay, so this part is multiplied by this. I will put two parentheses here. Then this one is multiplied by secant squared x. Then you have minus 2 secant squared x plus 1. Then everything is multiplied by dx. Okay, then distributing secant, this one distribute to the first term, multiply to the first term and also the second term. So we have now integral of tangent squared x times secant squared x. Okay, that is for the first term. This one multiplied by the first term. Then plus we have this one, secant squared x times 1, so that is secant squared x. Then minus 2 secant squared x, then plus 1, then the whole thing is multiplied by dx. Okay, then distributing the integral sign and also the dx. So, or before that, we can combine. We have similar terms here. This one, we can combine them together. We have positive secant squared x. We have negative 2 secant squared x. So combining them, so we have integral of tangent squared x becomes secant squared x. So this one becomes minus secant squared x. There are two parts here, negative. There's one part here, positive. So when you combine them, so we have this left. Then plus 1 times dx. So distributing now the integral sign and also the dx. So we have integral of tangent squared x secant squared x dx minus the integral of secant squared x dx, then plus the integral of dx. So we're now integrating each term individually. And if you can still remember from our integral calculus, we have a formula. Integral of secant squared u du so integral of secant squared u du, this is equal to tangent u plus c. Okay, and we also have a formula from our differential calculus. The differential of, or the derivative of tangent u with respect to u is equal to secant squared u. Cross multiply du, so you have the differential of tangent u is equal to secant squared u du. Okay, so we have to make use of this formula in solving these parts here. So from here we can have our n is equal to 2. Then we can let u be equal to tangent x. And from here, I'll just do this directly or immediately. So our du is simply our formula. Now derivative of tangent u is simply secant squared u du. Alright, so we can have here the du is simply secant squared x dx. Okay, so we'll continue it here. So to continue, so this is equal to integral of, so using the power formula, so we can, instead of writing tangent x, our tangent x equal to u, so this will be u to the n. Our n is equal to 2. Then our secant squared dx, our secant squared dx, which is this one, secant squared dx, is just equal to du. Okay, so therefore this will be times, instead of writing secant squared x dx, secant squared x dx is equal to du, so times du. Then minus, so integral of secant squared x dx is equal to, that is, okay, I'll just rewrite it, class. Integral of secant squared x dx and plus the integral of dx. So using the power formula, what is the power formula? in integral of u to the n du is equal to u to the n plus 1 over n plus 1 plus c. Okay, so we have to make use of that formula. That is the power formula. Alright, so to continue applying that formula, so we have u to the 3 divided by 3 minus, using the formula for integral of secant squared u du is equal to tangent u. Okay, so our u is equal to x, so this is tangent equal to tangent x. Then the integral of dx is equal to x, then plus c. Okay, so what is our u? Our u is equal to tangent x, right? So substituting, so tangent x to the power 3 divided by 3 minus tangent x plus x plus c, or our answer is, our final answer is 1/3. Okay, 1/3 tangent x, and you can put the exponent here like that, then minus tangent x plus c. So this is our final answer. Okay, so hope you were able to follow the process, and if you have any question, you may send me your message in our GC. Okay, thank you very much, class. See you again in our next video. Bye.